5.2 example 2. This wants us to look at a cos function, and there's definitely a few more transformations happening here to try to make this a little bit clearer, I hope. What I'm going to do is underneath, I'm going to write what the transform version would look like, and that's a times the cos in a bracket b, and I'll put theta instead of x minus c, and then finally plus d. And hopefully after that work that we've done in the earlier transformation chapters, you can take a look at that and identify that a is equal to -2, b is equal to 1. That's to say that there's no effect. C, this is the tricky one, is -pi. Because this is theta plus pi, that would have started before they simplified. That's theta minus -pi. And then d is equal to -1. Now, I think it is important that we are going to relate these to their transformations. And maybe I didn't leave myself enough room, but we'll sneak it in there. That if a is equal to 2, we have a vertical stretch by 2 and a reflection over the x-axis. That's a vertical reflection, we often say. Sorry, my x-axis trailed off a little bit there. When b is equal to 1, I'll write it, but we have a horizontal stretch by 1, which does nothing. If c is equal to pi, we have a horizontal translation pi to the left, and if d is equal to -1, we have a vertical translation 1 down. Now, all of that is wonderful, but I think it is good to summarize this as a mapping, and that's to say that x comma y, and I'm just going to put that this would be on y equals the cos of theta. That's our original graph in this context. What that is going to turn into is x minus pi, comma, -2y minus 1. And this set of coordinates is going to be on our function y equals -2 times the cos of theta plus pi minus 1. All right, now what we can do is we could use the mapping. We could do this piece after piece. I would highly recommend that you get comfortable enough with these that you're using your calculator for them. And what I'm going to do is I'm going to reveal this to you, and I would like you to kind of power through that calculator concept. And I'm going to put the points on y equals cos theta, just like I did on the last question. And I'll have to move this around just a little bit. But what I would like you to do, because there isn't value in this kind of, maybe struggle is not the right word, is if I looked at the points on cos theta, which are 0, 1, pi over 2, 0, pi, -1, 3 pi over 2, 0, and 2 pi, 1, we should be able to transform these onto the graph of y equals -2 cos, pi plus theta plus pi, and then -1 on the outside. Now, I'm going to just kind of let you guys pause that, and please try those coordinates, and I'll put those simplified points up here on the board, and then we can take a look at whether or not we're getting the same thing. Hopefully you had a chance to try those, and what I get them transforming into is that 0, 1 is going to go to -pi, -3. Then pi over 2, 0 is going to go to -pi over 2, -1. Then we have 0, 1, pi over 2, -1, and pi, -3. One thing that can help a little bit is that when you are subtracting pi, remember that pi is the same thing as 2 pi over 2, and that can help a little bit with these two values. All right, now your scale is a little bit different on your graph, and I'm going to kind of reveal what I have. And again, if you can get 1 or 2 rotations, typically that's enough to take a look at what the graph is. A little bit zoomed in for sure. The graph that you have has divisions of pi over 12. This graph only has divisions of pi over 3. Each of these ticks is pi over 3. But to kind of pull those points, and unfortunately, actually, the first point isn't on there, right? -pi, -3. -pi over 2, -1 would be right here. 0, 1 is here. Then we have pi, -3. This right here we didn't have on there, which is okay. We don't have the x-intercept, that's fine. And then up here, we have 2 pi, 1. And then what they've done is they've just reproduced that graph. Really important that this is still a periodic function. And if we take a look at that single full cycle, although technically it's a cycle in a bit, if I shift this over, we see that the graph repeats and then repeats again and repeats again and repeats again. There's definitely a couple different points you can see that. If we wanted a single rotation, I could look at this. And then what I could have is just shifting that over, produces that, well, badly drawn, but we can see that it's a repeating function or periodic function.